Okay, guys, I got a pretty quick video for you today. Basically, we're just doing a little bit more practice with logarithms, getting used to them. It's important to do a lot of practice with these because it's such a different idea. You know about exponents, but logarithms, thinking about it backwards takes some adjusting. So we're going to move kind of slow and just make sure we've got it down. This section is technically called logarithms with other bases, but I'm just going to basically show you how to solve the problems. And the first thing you need to know is that a logarithmic expression like this one is exactly the same as the exponential expression a to the c equals b. And that's not a new fact, that's just restating what we started talking about last time. And it kind of goes in this little circular pattern. The base a to what I would call the quote-unquote answer c equals b. So the log is the exponent. If the log equals c, then that's what goes in the exponent spot. So we have three styles of questions here, and I'll just give you an example of each. Number one is, what if the argument is the unknown? For example, log base 5 of x equals 2. So the 5, the x, and the 2, those are our three spots, the a, the b, and the c. And any of those three could be the unknown, and you need to know what to do in that situation. So basically what this thing is saying is, what do I get when I take 5 and raise it to the second power? Because remember, it goes in this little circular pattern. This to the this equals this. Or in other words, 5 squared equals x. So if you get it out of log form and into exponential form, it really starts to, make a lot of sense. And 25 equals x, and that's nothing new. So it's just a matter of translating this new notation and this new idea of a logarithm into something that you already know about. Okay, so let me get another good color. This one's pretty. It's a nice color. How about one like this? Log base 3 of 3 equals x. In this case, the logarithm, the x is the unknown. It's over on the right by itself. So what this is saying is, what do I need to raise 3 to get 3? All right, and that's almost, hopefully that comes to you pretty quickly. 3 to the what equals 3? Well, x has to be 1 because 3 to the 1 equals 3. If you get one there that's not so obvious, and you end up in this situation right here, and it's not one where you can just look at it and see, remember how we solved equations where the unknown was in the exponent spot? How do you get the little unknown down out of the tree? Same way you get a little kitty cat out of a tree. You log both sides. Log of 3 to the x equals log of 3. The log causes the x to fall down to the front. X log of 3 equals log of 3. Divide both sides by log of 3. And log of 3 over itself equals 1. And you wouldn't really go through that process for this particular example, because if you look at 3 to the x equals 3, you should immediately know that x equals 1. But just to show you, in case it doesn't pop out at you, you can still use the log both sides method to end up solving for x. Okay, and the third style of question is one where the base is unknown. For instance, log base x of 64 equals 3/4. So what this is saying, if you put it into exponential form, this to the this equals this. X to the 3/4 equals 64. If you think it out, you might be able to figure that one out, but if not, the standard way to solve one like this is to do the opposite, or the inverse power of 3/4. If I had x squared equals 81, I would raise both sides to the 1/2 power, but I would think of that as square rooting. Likewise, I did that because 1/2 is the opposite of 2. I'm going to do the same thing over here except with the opposite of 3/4. X to the 3/4 to the 4/3 power equals 64 to the 4/3 power. All right, you know what you do to one side, you do to the other, so that shouldn't bother you. Why I chose 4/3? Because 3/4 times 4/3 is 12/12 or 1. And I just get 64 to the 4/3 is my answer. And I think, well, let me make sure I don't mess that one up. 64 to the 4/3. 64 to the, whenever you do a fractional exponent, put that fractional exponent in parentheses like that. And 64 to the 4/3 is 256. All right, so the fastest video on record to this day is right here. 3 styles, and all of them involve the connection between a logarithmic expression and an exponential. They mean the exact same thing, they're just written in a different way. And any part of it can be the unknown. Unknown argument, like here in purple. Unknown answer or logarithm, like here in puke green. And unknown base, like here in red. All right? So we will do quite a bit of practice in class. I will see you then. This is Young, and I'm out.